Number 13 says an initial amount of money is placed in an account at an interest rate of 1% per year compounded continuously. It's compounded continuously. We're going to use a base E formula. It's going to look something like this. PE to the RT. If it's a positive interest rate, R is positive. If it's decreasing, R is going to be negative. So, after 4 years, there's $3,143.25 in the account. Find the initial amount placed in the account. So this is the final amount, $3,143.25. We want to find the initial amount that we put into the account. E, my interest rate is 1%, and 4 years is my time. So if I want to solve that for P, what would I do? If I want to get the P by itself, how would I move that to the other side? Divide, exactly. I'm going to divide by that. So I'm going to take $3,143.25. I'm going to divide it by E to the, and if I just multiply that out, 0.04 power. So we are going to take $3,143.25 divided by shift, natural log to get the E, and then in parentheses behind that, we're going to put the 0.04. So we have 3,020, and since it says round to the nearest cent, even though it's 0 cents, I'm going to put it there so they know that I did round it to the correct spot. Gavin, you get that one when you got it punched in?
Yeah.
Your calculator works a little different, so holler at me if you're getting a different number. Oops, we already did 11. Number 14 then. Suppose that the number of bacteria in a certain population increases to an exponential growth model with a growth rate of 27% per hour. Suppose also that the sample here of 2,000 bacteria is obtained from this population. Find the size of the sample after 6 hours. Round your answer to the nearest integer, to the nearest whole number. So, PE to the RT. We started with a sample of 2,000. We want to find the sample size after 6 hours. So 2,000 is what we started with. E, our rate, 27%. Our time, 6 hours, and we're finding the ending amount. And so we don't have to really move anything around. We just have to plug it into our calculator. So on your calculator, again, you're going to put the 27 times 6 in parentheses. And it should look something sort of like that, at least on the Casio one. Oops. Parentheses, 0.27 times 6. And so to the nearest integer we are getting
10,106.
exactly 10,106. So we started with 2,000, and after 6 hours we're already up to 10,106. Number 15, the mass of a radioactive substance follows an exponential decay model, which tells me that my rate is going to be a negative rate. Decay rate of 8% per day. The sample of this radioactive substance was taken 3 days ago. If the sample has a mass of 3 kilograms today, find the initial mass of the sample. Round your answer to 2 decimal places. So take a stab at what we should write down for our equation.
E to the 8% times 3.
So here's our normal one. I'm going to put equals A because that's going to be our N. What things do you know? So, is this 3 kilograms the amount we started with or the amount we ended with? Ended with. So that's going to go over here, right? We're looking for how much we started with. What was the initial mass? Our rate. What are we going to use for our rate?
8%.
But since it's a decay, we're going to use negative 8%. And my time? 3 days ago, right? So, on this one again, if we want to solve it for P, we are going to end up dividing. So P is going to equal 3 divided by E to the negative 0.08 times 3. And we are rounding our answer to 2 decimal places, it says.
Yeah. 974.9.
Nope. Oh, you gotta get the times in the parenthesis with the 0.8. Right, those have to go together. 0.8 times 3, otherwise they'll multiply that first. Try again. That's what I'm getting. Yep. So we get 3.81. So it started at 3.81 grams. It's decreasing at 8% per day. After 3 days, now we're down to 3 grams. Didn't go down a whole lot, but it went down a little bit.